Hey guys, it's Duncan from 21417A Robotics, and I'm just here to do a little bit more of an in-depth explanation of a robot than was in our reveal. So we're going to start with the drive. So as you can see, we have a 4-motor drive on 300 RPM 4-inch Omni wheels. It's actually not just a 4-motor drive. So it is a 4-motor drive when the cat is engaged. However, we have these 4 motors in back. It's two 11-watt motors and two 5.5-watt motors stacked on top of each other. And those power the Cata when we have the Cata engaged and are using it. And then we can switch those over to the drive when we want a 7-motor drive using a PTO. So you can see that these gears switch over and now it's a 7-motor drive. It had a lot of good pushing power. In the scrimmage we went to, we were able to push around most of the robots there and had no issues with that. And then we can switch it back to the catapult when we need to. And those gears are usually spinning when it's switching over a little bit just to help mesh them. And then, so now those are on the catapult. So when we spin these motors, you can see that the catapult rewinds. And for the Cata, we were just using two 12-tooth pinions as the slip gears. You can see we have the chain here. That was just a spacing thing. And then we have the ratchet at the side. And the ratchet was just to keep the catapult down when we disengaged or re-engaged the PTO, just to keep everything sitting where it's at. So a little bit on the Cata. So as you can see, we have these 2 front wedges to force orientation of the robot or of the tri-ball. So you can see that I can drop one of those in and it'll spin around and autocorrect, and that was the orientation that we were firing in. And then we have the teeth in the back to hold it, and so you can see that just doing that we can shoot a tri-ball, and that was pretty consistent. We were able to pretty consistently make it on tri-balls into the goal in several fields. So we were actually pretty happy with the Cata on this, and of course having 3 motors on this, or the power of 3 motors, we were able to power the Cata with 10 rubber bands that were doubled up, and that just gave us a ton of power, made sure it went into even tight tolerance goals, and also allowed us to do shots from the match load section of the field. So that power was really handy. All the motor power on the Cata was really handy for fast rewind. It is 33 RPM, so that works out to about 100 shots per minute. So we were having no issues with the Cata rewind and doing match loads. The bigger problem was actually just having people being able to load the catapult fast enough. So we had a really fast rewind time. For the match loads, we have this little ramp that just is pneumatic powered. It just sits up a little bit and lets us put the tri-balls up farther, and that just makes the arc higher because of where it sits on the Cata. And so that allowed us to shoot the tri-balls over the barrier and into the goal. So that was pretty handy. We didn't have any issues with that mechanism of the robot. And moving on to the wings. So the wings, let me unfold this. So we have really, really long wings on this robot. So the wingspan of this robot is 35 inches long, which is almost as wide as the goal is, between the little circle like brackets at the bottom. So we were able, if any tri-balls were in front of the goal, to push it. And as you can see, the mechanism that we're using to expand those wings, so we had the cylinder mounted really close to the drive. It's only 4 holes out. So when the tri-balls, when we were pushing those, there's a lot of leverage against that cylinder out here. So we actually solved that problem by putting a locking mech on. So it's a piece of half-cut high-strength axle, just rubber banded over to the side using a piece of latex tubing. And so when there's pressure on the cylinder and any pressure is applied to the outside of the wing, that forces this bar in. And then there's a little Lexan catch on the side that prevents this high-strength axle from slipping back, and it locks the wings in place. And I can apply a lot of pressure onto the wing without it being back driven at all. And that actually kept all the stress off the cylinder. It allowed us to push way more tri-balls in than we would without it. And it also retracts fine. Here, I can retract it and you can see. So that mechanism we were actually pretty pleased with. It worked really well. You can see that no problems, no back driving. And then we just had the wedges on the wings to help push balls over the barrier. So that's pretty much it for the wings. So that is all the systems we're actually gonna go over for this robot explanation right now. So I hope that helps explain some of the stuff about our robot. If you have any questions, you can post those down in the comments. With that, good luck in over under, and maybe we'll see some of you guys.